What does it mean to have conservative force? Is first of all, the mathematical real meaning is this: the curl of something, determinant basically of this format of a force equals zero, then it's conserved. And curl can mean a lot of things. A lot of times it has to do with rotation, but in this case, it's not. Um, in 2D, it is this format over here. Find if something is conserved. There is just a simple derivative and nothing special. It's just solving that question, solving this format over here. And we get that as conserved because we took the derivative over here. I did a simple question, nothing too difficult. Um, but another way, a more conceptual way to say is another way is like the direction does not matter. Uh, and more of that it comes from energy itself, so we won't be talking too much. But over here, you can kind of see two different examples of gravity and uh, near surface and versus general. Both of them is zero, as you can see over here, and it makes sense once you actually just plug it into a curl. Now, with that said, the friction is not conserved. Maybe I should have wrote over here v equal velocity because I didn't write that, but I thought that would be pretty obvious. But now thinking about it, it's not, so I'm going to write that later on. Friction is the opposite of velocity, and this velocity vector allows us to have a derivative in different directions, allowing this thing to not be zero, cannot be zero, it would be a whack number because of these directional velocities, one way or another. Over here is another way to visualize the direction does not matter. You can go from one space and go like this and go to the same place. And this over here will show zero work done. And that's how force conserved. Maybe I need to write more words over here because I realize it's kind of less, I need more words. Here's a basic example of a constant force. And we do a more advanced example. My favorite is kind of this one because it has two variable, and initial and final. And you'll think, and that's kind of hard. That doesn't make any sense. But it makes sense if you think about it. 1 and 10. So it's like 1 and 10. And then it's 0 to 5. So 0 to 5. And it's just I and J related, correlating, and just do that integral and you're done. Another one I love is this one because you're given this unit and you get it to, you just take another derivative, two derivatives, you get acceleration, you plug into force, and you know this is 1D because it's just X. So you can use W equal FD and you get everything because cosine is just the angle of zero, or assuming I should probably write that down.